Welcome to today's tutorial. Kindly subscribe so that every time we post a video or tutorial, you'll be the first one to be notified. So today we are looking at solution to near homogeneous differential equations. Last time we looked at a solution to homogeneous differential equations. So if you have not already checked on that, kindly look at how from our previous video or tutorial, and feel free to comment, to leave your comment, so that I'll be looking at what you need to look at. So welcome. So we are looking at solution to near homogeneous differential equations. So divination of us. So a DE of this form, dy dx over ax being equal to ax plus by over c over px or plus qy of r, which if you look at these just linear equations. They are linear equations. We call them this kind of DE, we call it near homogeneous differential equation. So if you come up across this kind of DE, when this is a differential equations, it's only differential equations, and it is in this form, like it's a linear equation dividing another linear equations, then you will classify this one as near homogeneous differential equation. So what you normally to do, we change the DE to homogeneous. Remember, it's near homogeneous. Now we want to transform it to homogeneous. So if we want to change it to homogeneous, we normally substitute it using these kind of substitutions. We use x being equal to u plus alpha, and we use y being equal to v plus beta. If you rearrange, you can find that u is same as x minus alpha and v is same as y minus beta. So why are we having this substitution? We want to transform this kind of near homogeneous to homogeneous DE. So what are these alpha and beta? Of course, these are the solutions to these two equations. If you solve them simultaneously, the answer that you get is value of x and y for these two. They are actually point of intersection of these two lines, because of course they are lines of lines, and those will be your respective values of alpha and respective for beta. So if we want to get already I have mentioned that alpha and beta solutions to these equations, linear equations. So when you solve them, the value of x is alpha and the value of y is beta, and which are the point of intersections. So example, let's look at an example. So you have an DE, solve this DE, and you can see the numerator of the DE is actually an linear equation, and the denominator is also a linear equations. So we want to solve this. So if it looks like that, this is near homogeneous DE, and now let's solve it. So we remember how we used to solve simultaneous equations. So rearranging, we find that, and we can solve this simultaneous equation with either of the method. Remember, in my tutorials up there, you can see that I've shown you different ways of solving simultaneous equations. So you can follow that link up there and try to solve this equation using that tutorial that I gave. So solving this, you'll find that beta is 1, and even alpha is 1, and also beta is 1. Then I want you to recall something. If I have an du dx, dv du, it can be expressed in this form, because basically this can cancel with that, this can cancel with this, and what I'm left with is basically being dv du. It's actually dv du. So if you look at this clearly by dividing, you'll find that dv du is basically that. It's basically that. dv du is basically that. In case you have question on this also, you can also ask me how did this happen, and I will be glad to show you how that happened through down there, my comment down there. So dv du is same as that. So having this relationship and having gotten the value of alpha and beta, we can see it can substitute. So now in our equation there, remember what we said. Our x is given by u plus alpha. Our y is given by v plus beta. So this is actually v plus beta for y, and this is actually u plus alpha from beta. So substituting the equation, we end up having this, and this base here is from the previous relation that you have seen. Dy dx is same as dv du. So if you simplify this, you can see you are getting this, and this now is giving us a homogeneous equation, and from our previous again tutorial, we can look at how we solved homogeneous equations. So this has been converted to homogeneous equations. So check on the link above there and see how we can solve homogeneous equations. So we just substitute this in w equal to v over w, which again looks like that, and if you do that, you can see that's also true. That is also true. dv du gives us that. So now we can substitute, and that's true. That is true. That one, rearranging, and this is true. And then we have this. That's also true. That is also true. So in case you have question on either of the expansion here, or you're not arrived to what I've arrived to, leave a comment. I'll be able to guide you on how we are arriving to this kind of solution. So next we integrate. Remember, in this case here, to this far here, after rearranging, you'll find this now will change to separable OD, and after that we just apply integration, integrate both sides, and you can see this is now just rearranging. Don't ask me why I'm getting the negative from. If you rearrange this, factor out negative sign, if you get this, so it's nothing new. So now we can solve the right hand side. You can solve this side using fraction partition method. And we have this. If you solve that breaks to that, we have that. So if you have a question on that, also leave a comment. I'll do that for you. So if you do that, integrating, you get that, and therefore you get that, and you'll see that we are getting this. But remember, we substituted w to v over u, so substitute, and we know our v is that and our u is this. So substituting back and solving, you'll find we are getting this kind of equation, and that's kind of solution that we expected. So we have solved the near homogeneous DE. So first, what are we doing? We are converting this near homogeneous DE to homogeneous DE, and then become separable. And after separable, we are getting the solution and the substituting respectively. So kindly subscribe so that every time we come up with this next tutorial, you'll be the first to get the notification. Thank you for now. Thank you for your time.